Hey guys, I'm just providing a lecture for assignment 3.2. This is the day that a lot of people were absent. So the point of this lesson is about triangle similarity. So let me draw a couple of triangles. This triangle is 1, 2, 3. This triangle over here is 10, 20, 30. So the first lesson in this unit, we talked about scale factors. And here the scale factor is going to be 10 because our old one, this is our old, all the sides of our old one get multiplied by 10 to produce the sides of our new one. So now let's take a look at the angles. Now, if this is a 90-degree angle, would I expect the 90 to be multiplied by 10 to make this a 900-degree angle? And the answer obviously is no, that would be crazy. So with similarity, the side lengths get multiplied by a scale factor, but the angles will all stay exactly the same. Now, when we're proving that two triangles are similar, we would, technically speaking, have to prove 6 different things. Let me show you the 6 different things. So here's a triangle. Let's do 1, 2, 3. And now this one, let's do 6, 4, 2. So these triangles are similar because 1 divided by 2, this one divided by this one, is equal to this one divided by this one, which is equal to this one divided by this one. And also all the angles in between, this angle matches this angle, that angle matches that angle, and that angle matches this angle. So those are the 6 things. 1, 2, 3 pairs of proportional sides, and then 1, 2, 3 angles that are congruent. But there are some shortcuts. There are 3 shortcuts to prove that triangles are similar. Now these shortcuts have, let's just go through these. So the first one is if this triangle is 90 and 30, and this triangle over here in a totally different orientation is 90 and a 30, then I know that those 2 triangles will be similar. Now it's going to be super powerful for a lot of real-world applications. And let me just say this one more time. If we have 1 and 2 pairs of congruent angles, then that proves similarity. Now this little wavy shape, that means similar. So if you get 2 angles that are similar, then the triangles themselves, if 2 angles are congruent, then the triangles are similar. That's the first theorem, AA. Now the second theorem is like this. We got 1, 2, 3, and now let's do 7, 21, 14. Here these guys are proportional because let's do this one over this one. 7 over 1 is equal to 21 over 3. It's equal to 14 over 2. All these are equal to 7. So because of that, because you have 1, 2, 3 sets of proportional sides, we're going to call this SSS. And SSS proves similarity. Now finally, the third one is a little bit of a hybrid between the 2. The third one goes like this. You have 1, 2, and here we're going to do 8 and 16. So here I have a side that's proportional to another side, and these guys are proportional, but in between them, they have a congruent angle. So this we call it side, angle, side, side, angle, side. So SAS is going to prove that those guys are congruent. Okay, so there you have it. Those are our triangle congruence theorems, and that should be enough to do the homework. Let me go over one or two questions on the homework while I'm making this video. One thing that we did in the homework that you probably haven't done in a while is solve equations like this. So this is the first question in the homework. And on this one, what we're going to do is to solve it, before we can do anything, we have to use the distributive property. So that 2 hits both terms inside the parentheses. And now we can call that 2x plus 4 plus 3x, and then everything else comes down. So when you solve these equations, just do one little tiny thing at a time. Don't try to be a hero and do 20 steps in your head. All I'm doing from here to here for those two lines is I'm using the distributive property to simplify. Okay, now we can combine our like terms. So the 2x and the 3x is combining to 5x. And again, I'm only doing one single thing. All right, and now from here, we're going to take away 4x from both sides. Take away 4x from both sides. And now that's going to give us x plus 4, those cancel, equals 7. And you can solve it from there. Now, another question, I won't solve this entirely. This is the second question on the homework, is you have a 5 minus 3, x plus 2 equals 2x minus 11. Now, this also caused people some confusion. Is this a 3 times x, or is it a negative 3? Well, it turns out the most efficient way of doing this is to treat this as a negative 3. And that negative 3 is going to hit that, and the negative 3 is going to hit that. So just rewriting it, 5 minus 3x, negative 3 times 2 is going to be negative 6, and then I'll leave the rest for you. Question 2 on the homework, we should also go over. We've got this kind of thing, x plus 2 over 7 equals x over 5. We're going to do the same thing we did last time, which is cross multiplication. So we're going to cross multiply this direction. So this is 5 times x plus 2. Now it's 5 times all of x plus 2, not just 5 times x and then plus 2 as an afterthought. It's 5 times x and 5 times 2. And then we multiply there, 7x. So using the distributive property, now we got 5x plus 10 equals 7x. And then you can solve from there. Subtract 5x from both sides and you're good to go. Okay, I'm just scrolling over the homework right now, seeing if there's anything else really tricky. Let's do question 7 on the homework, or at least start it and get it set up. So here we have 10, 17, and x. And then over here, we've got 14, 12, and y. And then this angle and that angle are the same, and then this angle and this angle. So by AA, similarity, we know the triangles are similar. So now, let's set up some equations. I'm going to color these things to make it a little bit simpler. This leg right here corresponds to this leg. I'm going to call these my blue legs. So 10, we'll put everything from this triangle goes on top of my fraction. Everything on this triangle goes on the bottom of my fraction. So 10, that blue leg is going to be on top. 14, we're going to put that blue leg on bottom. And now right here, let's change this to green. We have x, and we have, this was a 12, right? Okay, so we got x. Remember, this is my top. So everything here is on top. The x is on top, and the 12 is on bottom. So 10 and 14, these correspond with each other. So 10's on top, 14's on bottom. X is equal to 12. And now from here, we're just going to cross multiply this out. And we got 120. Cross multiply this equals 14x. Divide both sides by 14, and you're good to go. Now you can also set up an equation with, let's give this, what's a good color? Let's do red. Oh no, we already have red. Let's do purple, or whatever this is. Lavender? All right, so now we can do 10 over, let's write our blue ones. So 10 over 14 is equal to, and now let's do our lavender ones. This is going to be 17 over y. Okay, and then you do the same thing, cross multiply across, so that's going to be 10y, cross multiply this, whatever 14 times 17 is, and then you just keep on cranking it out. So the main thing on these questions is just to be really consistent on which numbers go on the top and which numbers go on the bottom. And that's why I kind of do this to keep track of that. Okay, good luck guys. Let me know if you have any questions.